This video is one of a series covering the released Ohio State math questions between 2017 and 2023. Expressions and equations make 1/3 of the test questions. Use numbers expressed in the form of a single digit times an integer power of 10 to estimate very large or very small quantities and to express how many times as much one is than the other. For example, estimate the population of the United States as 3 times 10 to the power 8, and the population of the world as 7 times 10 to the power 9, and determine that the world population is more than 20 times larger.
Hello and welcome. Let's see what we need to know before we get into the questions. Powers of 10. Here are the positive powers of 10. 10 to the power 1 is 10. 10 squared is 100. 10 cubed is 1000. 10 to the power 5 is 100,000. So you notice here 5 zeros, 4 zeros. Now the negative powers of 10, 10 to the power negative 1 is 1 over 10, which is 0.1. 10 to the power negative 2 is 1 over 100, that's 0.01. 10 to the power negative 3 is 1 over 1000 is 0.001. Now you notice here this is negative 3. Here you have 3 digits. Only 2 zeros after the decimal point. 10 to the power negative 5, for instance, is 1 over 100,000. That's 0.00001. You count this 1, 2, 3, 4, 5. 5 digits after the decimal point. Now, if n and m are integers, 10 to the power n is 1 over 10 to the power negative n. 10 to the power negative n is 1 over 10 to the power n. And this one here is really important. We're going to be using it quite a bit in this video. 10 to the power m divided by 10 to the power n is 10 to the power m minus n. Single digit number times an integer power of 10. 300 is 3 times 10 squared. 7,000 is 7 times 10 to the power 3, so you are adding 3 zeros here. 5 millions, 5 times 10 to the power 6, 6 zeros. Now when it comes to small numbers, less than 1, 0.007, that's 7 times 10 to the power negative 3. This one here is, you count 1, 2, 3, 4, 5, that's 10 to the power negative 5. So 2 times 10 to the power negative 9, negative 5. Think of it as if you are moving this decimal point 1, 2, 3, 4, 5 to get it to here. Then you have to get 10 to the power negative 5 to recover the original value of the number. Then same thing goes for this. Now 10 to the power 6 divided by 10 squared is 10 to the power 6 minus 2. 6 minus 2 is 10 to the power 4. Here 10 to the power 6 divided by 10 to the power negative 2. You have to be careful here. You have to put 6 minus 2, which is 6 plus 2 gives you 8. This is 10 to the power 8. Again, similar here. 10 to the power negative 2 divided by 10 to the negative 8. 10 to the power negative 2 minus 8. Minus 8 is plus 8. Minus 2 is plus 6. Last one here is 10 to the power 6 divided by 10 to the power 8. 6 minus 8 is minus 2. Now we get to the questions. Every time you see this picture, you may pause the video and solve the problem and come back and check your answer. Which expression is equivalent to 0.0005? This kind of questions, any student should be able to do it without any difficulty. So they gave you options here. If you look at these options, this one is not a good option. That's 5,000. That's 50,000. So those can't be equivalent to this number here. It's your choices are this one or this one. But here's how you do it. So 0.0005 is is 5 times, you count 1, 2, 3, 4, 10 to the power negative 4, and then you just got it right here. This was one of two questions in 2021 on this standard. This question, again, level 1, it should be easy to do. So you get this, you count here 1, 2, 3, 4, 5, that's 10 to the power negative 5. Don't forget the 7. 7 times 10 to the power negative 5. This was one of two questions in 2018 on this standard. Here's another one. A people weighs 3 times 10 to the power negative 2 pound. A large boulder weighs 9 times 10 to the power 3 pounds. How many times larger is the weight of the boulder than the weight of the people? So this is larger than this. Obviously, this is a division problem. You set it up this way. 9 times 10 to the power 3, the boulder. People is 3 times 10 to the power negative 2. 9 divided by 3 is 3. 10 to the power 3 divided by 10 to the power negative 2, that's 3 minus 2, that's 3 plus 2. So you get this one, which is 300,000. So your answer could be 300,000 like this, or this. Both are acceptable. This was the only question in 2023 on this standard. This is level 2 question, the same as the one before. The radius of a fluorine atom is about 5 times 10 to the power negative 8 millimeter. The radius of a strontium atom is about 2 times 10 to the power negative 7 millimeter. About how many times larger is the radius of this one here? The strontium is larger, so that should go on the numerator than the radius of the fluorine atom. Those are chemical elements. So you set it up this way. 2 times 10 to the power negative 7 for this here, divided by 2 times by 5 times 10 to the negative 8. You get 2 divided by 5 is 0.4. 10 to the power negative 7 minus 8, that's plus 8. That's 10 to the power 1. So you times this, you get 4. Your answer is 4. This was one of two questions in 2017 on this standard. Now, a few questions here, a few examples here from practice tests. They all are similar, just to get you the idea. An incomplete sentence is given. The value of 2 times 10 to the power 14 is blank times the value of 4 times 10 to the power 6. So this one is larger than this. You just set it up this way. 2 times 10 to the power 14 divided by 4 times 10 to the power 6. 0.5 times 10 to the power 14 minus 6 is 8. So this decimal point is going to move 8 position to the right, so it gives you 5 and followed by 7 zeros. And that's 50 million times. Similar question, an incomplete sentence is given, the same thing, so you could just put this divided by this. 8 divided by 4 is 2. 10 to the power 10 divided by 10 to the power 7. 10 to the power 3, and that is 2000. Same thing, go quickly on this here. 9 divided by 3 is 3, and 15 minus 6 is 9. That's 3 followed by 9 zeros. Same thing, you do the same thing here. I'm going quickly on this. 6 times 10 to the power 11 divided by 2 times 10 to the power 9. Get this, you get 300. Now, This example is interesting. It's a level 3. It has two parts. So you can really, it's not that complicated if you organize your work. So the masses of two animals at a zoo are described where B and C are integers. The mass of an African elephant is 6,125,000 grams, about 6 times 10 to the power B. B is unknown. The mass of a silverback gorilla is 185,000 grams, about 2 times 10 to the power C. What are the values of B and C? Part B, using these estimated values, the mass of the African elephant is about 3 times 10 to the power M times the mass of the silverback gorilla, where M is an integer. What is the value of M? So let's get going with this. Part A, elephant is 6,125,000. When you round it, it gives about 6 million. That's 6 followed by 6, 0. That's 6 times 10 to the power 6. The gorilla, 185,000. That's 200,000. That's 2 times 10 to the power 5. So clearly B is 6 and C is 5. B is 6 and C is 5. You put them here, you get 1 point. Now we go to part B. Elephant over gorilla. 6 times 10 to the power 6, this number here, divided by 2 times 10 to the power 5. 6 divided by 2 is 3. 10 to the power 6 divided by 10 to the power 5 is 10 to the power 1. Now look at this here and this here, and you find M to be equals to 1. This was the only question in 2022 on this standard. And that's it for today. Thank you and see you soon.
Thank you for watching. If you would like to have a copy of the PowerPoint presentation, please leave your email address in the comments section, and we will be happy to email you a copy.